Yeah, so you just take square roots. And so these things are used in perceptual audio coding. And why? Because in an instantaneous processor, you don't want the window to spread. In other words, you take a chunk of signal, you window it, you FFT it, you quantize it relative to the masking threshold. You want to minimize your bit rate, and then you inverse transform. And you would like to have the original frame. You don't want to have done anything to it. You're doing compression. So anything that goes outside of the window is noise. And so being able to apply the window again is a good way to get rid of coder noise. And so that's why it's always used in perceptual audio coding. You also use it in timescale modification because this is an example where you're not trying to filter the signal, you're not trying to smear it. The window should not grow in time. Well, other than due to the timescale. So the window gets stretched and squeezed, but outside of that window, it should not be, there should not be any new information. And the Fourier dual of timescale modification is pitch shift, or frequency scaling more precisely. So if you're doing frequency scaling, time scaling, perceptual audio coding, or Chet's project, then Chet's project is an example where you can benefit from a post window. And that was one of the, I think that was the breakthrough that got rid of the frame rate distortion, right? So that actually made the difference. That was the step from audible frame rate distortion to inaudible under most conditions.
That was nice.
Yeah, so just think about whether you need your windows to, and actually that's a really interesting case because you are doing an effective convolution processor. In other words, frames are spreading through time, but not on an individual frame basis. It's basically information being transferred from one frame to the next frame in a meta sort of way. You're sort of adding it back in, but it shouldn't come into the expansion of the filtered frame itself. So it's kind of an interesting example of an instantaneous STFT that's being, you've got memory of prior frames that's feeding in and giving you the effect of like reverberation and time scale, time spreading, but you can still use the post window because you've still got the individual frame being processed in an instantaneous manner. So that's kind of an interesting hybrid that I don't think I've seen before. So I think you do have a paper there. Yeah. So yeah, I think it's a new effect, new class of effects. There's a lot of stuff you can do with it. Okay, so. So the main thing that prevents you from using weighted overlap add is when you really do want linear convolution, so you really do have, ringing after your frame and before your frame, but you could at least apply a window around that. In other words, you know how far your filter goes, and if you went up to a higher power of 2 and you had some zero padding that you know the filter can't reach, you can at least zero that out, right? So you can zero out anything you know that should be zero.